Good day and welcome. In this tutorial, we're going to be looking at the various rating of the major appliances, or should I say components of solar PV installation. We're going to be starting with the inverter rating selection for homes. Now, in the past, we've looked at how to connect these various components together, but we need to know, how do we know what rating is expected of us to connect in our homes? Here is how we go about it. Please stay tuned and make sure you watch the video to the end. So, if you want to detect the inverter rating for your home and what appliances are to be connected to it, you're going to have to go through the whole appliances within that home. Say, for example, if you have 3 number of fans in your homes and 2 number of lights and 5 numbers of LED bulbs, or perhaps 1 number of TV. So you then take the wattage of each of these devices and multiply them by the amount of quantity that they are in the home. Then you take the total of it. As you can see now, we're going to be multiplying 3 times 75 will give you 225 watt, 225 watt, and 2 times 20 of course will give you 40 watts. And that of the 5 LED bulbs, you have 45 watts and 60 watts. In the total, we have 370 watts of power is required in the home where we are going to be applying. So there is always going to be an addition, of 25% safety factor. Now this safety factor is in an event where there will be perhaps a fluctuation, or perhaps somebody connecting a load that is not calculated by accident. So there's going to be need for this 5%. So this is how it goes. After multiplying it, you have 462 watts total load. Now to calculate the inverter ratings are in volt ampere. So the formula is going to be calculated in volt ampere. So the formula is watt over power factor. Now this power factor, of course, is usually we're going to be choosing that of 0.8, which is actually a more standard one. This will then give us the inverter rating of 578 VA inverter. But also in this case, there's going to be need for us to multiply these inverter rating by a safety factor of 25%. These we multiplied by 1.25, which will give us 100 divided by 80. That's equivalent of 1.25. So having multiplied to the 578 volt ampere, would have a 722 volt ampere, which would actually cater for our loads without any problem or any fault within the system. So this is basically how we could make our inverter rating. So however, you might not necessarily find the exact rating of 722 volt ampere in the market, but of course we're going to be taking the range of about 700 to 1000 VA. Ampere would actually do very fine for this inverter size. So another important aspect is the battery size selection for homes. So we're going to be looking at the battery rating as well. Having calculated the entire apparent power of or should I say the total load in the house, there is going to be need for us to also calculate the battery capacity. Now we're going to have to calculate the battery capacity from the total load, and the formula for calculating the battery capacity is watt times the backup time divided by the battery voltage that we're going to be using times the battery efficiency, and of course the inverter efficiency as well. In this case, we're going to be fixing a fixed value for the battery voltage to be 12 volt, and of course the battery efficiency to be 0.8, and the inverter efficiency as well 0.8, and backup time of 3 hours. So we're going to be having a total battery capacity of 180 ampere per hour. So this is basically how we take ratings for the inverter and the battery. This brings us to the end of this tutorial. Thank you for watching, and do not forget to hit the subscription button, and of course turn on your notification for when next I post a new video. Thank you.